Okay, welcome back. PV project. Right. So here we got we came up with a little counterweight here that's inserted into the plastic that threads in and out. This is just a little temporary solution. We're gonna think of something a little more elegant for that. So here is the gimbal, and actually no, wait, hold on, that motor's off. Let me turn it on. So you could see the little feedback mechanism here is bringing the. Hold on, what's going on here? Oh, I forgot to do something. Hold on, because I have the feedback. I have the speed really set low there. Okay, let's play a little bit of. I'm just playing a little bit with the direction here.
You want me to hold the camera?
Uh, yeah, I think I got it. Yeah, the tuning's pretty much okay with this. It's just it's. Well, as you can see, the positioning is pretty good. I mean, but there I'm just like dragging it left and right.
No. People gotta see these.
Okay.
Okay.
Yeah.
Please repeat.
Please.
Hear what you were doing here because people didn't see that.
Oh, okay. Yeah. Well, I want you to zoom in on the gimbal though.
Okay.
Can you zoom in on on this thing? I want to show the precision.
I want to see the screen, your hand, and the gimbal.
So this is 0.1 degree steps. Can you see it? You actually see it moving. Back the other way.
Can you move it with the mouse pad like this did before?
Yeah, sure. I can move it with the mouse pad like I did before. I'm giving it about what? Oh, let me see. Let me try something. There we go. How's that for a nice slow rotation? Hey?
What about the other motor?
You see if we can make it dance left to right.
Oh, and
This would
the
be like move to 45 degrees. Stop. Move the other way. Hold on. Oops. The pitch. The pitch. Ooh. It might like. Have I turned off? Oh, hold on a second. Oh, there we go. Now it dropped to the right angle. Okay.
there's the IMU,
So you could see it under? It's all
the
up.
green light.
And as you can see, like if you try to move it out of place, it just readjusts itself, eh?
It goes back to
That's pretty-
position
it
where you put
goes
it.
back to position. So, okay, next up,
Oh, I want to play with this.
let's put the let's get the Raspberry Pi on.
Oh, but
Yeah, this I have to readjust the. Hold on. The PID is not properly adjusted. Up.
do it again.
Let me put this in front of me. I get this feeling that the this motor is not. I'm not happy with the torque this motor is displaying. Um, it's just a little bouncy. Let's get rid of that bounce. Okay, I'm doing that on purpose. Oh, there we go. See how it's struggling a little bit? Hold on, let me tune it out. Just gonna tune out that bounciness. Hold on.
You tune it, huh?
Yeah, you see this thing, the problem is that we thought that we would be able to get, because this weighs about 2.5 pounds, and this motor is supposed to be able to handle that kind of weight. Unfortunately, it's a balanced weight, not an offset weight. So when you add the other weight on the other side, you get a whopping 5 pounds. So I think to be on the safe side, we need to rush a custom order of a motor a little bit bigger than this. It's got a bit more torque.
Yeah, if we make the whole thing for 1 inch diameter samples, because this thing is for 6-inch samples. Okay, you can hold the 1-inch samples in this, but it's very heavy and big. So it makes stuff complicated. But if you're going to use, like most of the time, like 1 to 2-inch, 3-inch diameter samples, this whole thing can be shrank. But if it works for the big thing, it will work for a shrinkage.
Shrinkage. Where's the road? Ouch. I think there's a hard limit. I mean a soft limit. So that's yeah, I'd love to measure this thing. Oh boy, I forgot to calibrate something, but it doesn't matter. Yeah, so that's a perfect 45-degree angle. And look, if you try to knock it off, I mean, it's... Ooh. Ooh. Come on, find your place, buddy. It got lost there for a second there, eh? Alright, I think it's time you stop. That's about 45 degrees. Oh, yeah. I mean, if you give it a tap, it'll correct itself. And if you try to force it, it's just trying to fight you, eh? Look at that. It's alive! It's alive! Yeah.
Yeah.
So if anybody's wondering how a brushless motor that needs 6 steps of commutation is actually getting to hold position and rotate like that, just call us at Sensorica and we'll explain to you how we did it.
Drones, everything.
So this is a hack, right now. So I mean, we chose all the parts during the second milestone, and then we discovered this open source. Hold on. Whoa. So then we were ordering parts, and we discovered this open source gimbal controller that essentially has the same chip that an Arduino Uno has, the FML 328P. 2 of the L6312, the triple phase drivers. I don't remember the exact number. L6234. Yeah, triple phase drivers. Exact same chips on and an FTDI driver. For less than it would cost to actually order only these 2 chips.
$30.
Yeah, awesome. So it's a little tricky with the FTDI driver, but we'll document it well. It's nothing serious. It's tricky on Windows. On Linux, it won't be that tricky. Yeah, we need to think of a routing system that goes inside the arms here. I was thinking about that. These are silicone wires. They're very, very flexible, so they don't hinder anything. And Yeah, so what do you think, Dan? When are we gonna have this thing ready?
It's alive.
Yeah, it's alive. Man, I really wish I think we're gonna we could get that motor shipped in 24 hours. It's a little more expensive than what we thought. It's like a $60 motor.
I can't believe this.
What?
Even if it's balanced,
What do you mean?
it can't hold it here, let's say.
No, it's having problems. I'm gonna run a few more tests. I'm gonna tweak it a little bit more, see if I'm giving it the max power that I could give it. Yeah, I'm gonna try with the power supply. I've been playing with the 12-volt battery. There's a power supply was all the way over there. Yeah. So this thing is made for a DSLR, and this is a little bit heavier than the DSLR. Eh? But I mean, it's a nice system. The precision is incredible. We're getting a tenth of a degree.
A tenth of degree error placement.
Error it depends on the.
Oh,
The error depends on the drift that the what's it called? That the accelerometer is experiencing. But that's calibration. So that's the IMU that came with this thing. We'll have to try with the Adafruit IMU, the Bosch chip, which basically auto calibrates itself. So the error is going to be it's like I think it's a 0.2 degree error. Yeah. But the accuracy is more is higher. So yeah, I'm happy with it. This thing we got fixed. So this thing I think what we should do is we should make it so that we could thread this thing in and out. And I think that was the design, right? So we're gonna have a nice little weight here.
but instead of being like this, it should be like that.
Yeah, it'll be like that. It'll just be like a weight that you turn, say like this, and it'll just over here. There's a slot to add a nut.